Hello students, now let's go for the further part. Now let's see the topic transformation of straight lines. Transformation of straight lines. Now you know, through any two points a unique line passes. Unique line passes. Okay. Now we consider line L. Line L, that is line passing through the points AB. So line AB, or that is same as line segment AB. Line segment AB. Okay, you know it is represented as AB. Now suppose we consider A having the coordinates x1 y1 and B having the coordinates x2 y2. Okay, where A is x1 y1 and B is what? x2 y2. Fine, this one. Now we transform line AB by transforming position vectors of A and B. Therefore, the transformed line L star, new line. Obviously, a point A will transform to new point, let we name it as A star. B will transform to new point, let it be B star. So, transformed line will be L star and it will be obtained by applying a transformation matrix on our original line. So, here our original line having the points AB and we will apply this T on them. Okay, that is same as, it will be, what is AB? It is x1 y1 x2 y2, and what is T? It is ABCD, general one, right? So this product gives us a matrix AX1 plus CY1, BX1 plus DY1, and AX2 plus CY2 and BX2 plus DY2. This one. Okay, and this is, or these are the coordinates of a new point wherever A will transform due to this transformation matrix, and these are the coordinates of new point wherever B will transform, right? So let it be x2 star, x1 star, sorry, it will be y1 star. This is x2 star and this is y2 star. As such, these are the points. So that is, suppose A star, B star. It will be A star B star, or here itself let me write here, this is A star B star will be this one, right? Now means what? We will get a line given to us that will transform to a new line. Now let me take a small question on this example. If we apply the 2x2 transformation matrix, 2x2 transformation matrix onto the points A 1 0 and B 0 1, then they are transformed to the points A star having coordinates 4 1 and B star having coordinates -2 2 respectively. What is the transformation matrix? What is the transformation matrix? Solution: let T be a matrix ABCD. That will be our transformation matrix, right? As A star B star is equal to what? AB, and we apply T on it, right? This is A star B star. Now what is given to us? A star having the coordinates 4 1 and B star -2 2. This is given. That is equal to what is AB? 1 0 0 1 into what? ABCD. So this is an identity matrix of order 2 by 2. So what is here? This is ABCD, right? So comparing this one as it is, comparing both sides or the entries of the matrices, what we get? This gives us A is equal to 4, B is equal to 1, C is -2 and D is 2. Fine. Therefore what we get? A transformation matrix T here is what? 4 1 -2 2. This is our required matrix or the answer of this problem. Now from this what we get, that under any 2 by 2 transformation matrix, a line is transformed to a line. The transformation has some properties because of which many geometrical results are predicted and can be used in getting a particular change in the object. Means now about the line we have to see some of the things. Midpoint transformation. Now there is a theorem. Midpoint will be transformed to a midpoint. Midpoint transformed to midpoint. Okay. Theorem. Under any 2x2 transformation, under any 2x2 transformation matrix, the midpoint is transformed to the midpoint. Midpoint of previous line must transform to midpoint of new line. So let's take example on this. Example. Show that the midpoint is transformed to the midpoint where A is 0, 5/2, B is 5/3, 0, and a transformation matrix T is 2, 0, 0, 3. These things with us. Now we have to show a midpoint of this line segment AB will be a midpoint of transformed line. Right? So now solution. Consider line segment AB. Consider line segment AB where A is 0, 5/2. B is 5/3, 0. Okay. Now T with us. What is T? Is 2, 0, 0, 3. So now what is midpoint here? That is midpoint. Midpoint, let it be M. M is midpoint of AB. Midpoint of AB. And that will be what? You know, midpoint of the, suppose A is x1, y1 and B is x2, y2. Then what is midpoint here? Midpoint will be what? x1 plus x2 upon 2, y1 plus y2 upon 2. This is a midpoint. x1 plus x2 upon 2, y1 plus y2 upon 2. Right? So in the same way, here midpoint of this AB, here this is x1, x2, y1, y2. So 0 plus 5/3 upon 2 and 5/2 plus 0 upon 2. That is, it is 5/6 and 5/4. This is a midpoint here. This is for your understanding simply, right? Now we transform the point M. Let us transform the point M first. Check what is the result. Now point M will be transformed. How does it possible? It will be obtained by applying T on M. So M is 5/6, 5/4, and what is T? T 2003. So the answer will be here. The answer is 5/3 and 15/4. 5/3 and 15/4. Okay, call it as equation number 1. Suppose we have been obtained the answer by applying a transformation matrix T on M, a new transformed coordinates of point M. Okay, now consider A star. What is A star? A star will be a position vector matrix obtained by applying T on A. So what is A? A having position vector 0, 5/2. T is what? 2003. Right? So now it will be 0 and 15/2. Similarly, what about B star? B star is B into T. So it is 5/3, 0 into 2003. So it is 10/3, 0. It is 10/3, 0. Okay. Now let's obtain the midpoint of A star and B star. If it will be same as this transformed point of the midpoint of AB, then we are through. The midpoint of transformed line segment A star, B star. Transformed line segment A star, B star. That will be, let it be M star. Okay. That will be what? Again, addition of these x coordinates by 2. So 0 plus 10/3 upon 2. Again 15/2 plus 0 upon 2. And that is what? It is nothing but 5/3 and 15/4. Call it as equation number 2. Now look at equation 1 and 2. So these are same. So the left hand sides are also same. Therefore what can we say? This M star is same as M into T. Therefore the midpoint is transformed to the midpoint. Midpoint is transformed to the midpoint. What we have done here, line segment AB, found the midpoint of AB, then we will obtain the transformed point of this midpoint, and then found A star B star and find a midpoint of that transformed line segment A star B star, and we have checked they are same. That is, midpoint is transformed to a midpoint. Now let's take a new example. Next example, find transformed midpoint of line segment transformed midpoint of line segment AB, where equation of line is 2x plus 3y equal to 4, and AB are the points of intersection. Points of intersection of line and the coordinate axis. This is also known as intercepts. X-intercepts and Y-intercepts. X-intercept is the point of intersection on x-axis, and Y-intercept is the point of intersection on y-axis. And here T is a given to us. It is 1, 4, minus 2, 3. Okay. Now simply we have to find a transformed midpoint. So no need to show the midpoint is transformed to midpoint. So here in a simple way we can do that, but for that we need to determine A and B first. What are A and B? So we have equation of line. What it is? 2x plus 3y equal to 4. So put y equal to 0. A is, by putting y equal to 0 we get x is equal to 2. So A will be 2, 0. It is on x-axis. And put x equal to 0, that will be B. It is on y-axis. X 0, then it will be 4 by 3. Okay. Now T with us. T is what? 1, 4, minus 2, 3. Fine. Now what is M? M will be what? Midpoint of AB. Midpoint of AB. That is 2 plus 0 upon 2 and 0 plus 4 by 3 upon 2. And that is same as 1 and 2 by 3. This is the midpoint. Now we have to determine a transformed midpoint. So simply apply this T on M. Therefore, a transformed midpoint m star is what? M into what? T, and that is equal to m is 1 2 by 3 and T with us 1 4 minus 2 3. So what we get? This simplification is, here we get minus 1 by 3 and here we get 6, right? So here m star having these coordinates. This is m star. Okay, here this one. Next example. The line segment between the points A, it is what? minus 1 minus 3. Line segment between the points A minus 1 minus 3 and B 3 4 are transformed to the line segment A dash B dash by the transformation matrix T, and that transformation matrix T is minus 1 4 4 2. Find the midpoint of A dash B dash. Find the midpoint of A dash B dash. So solution, here we have A minus 1 minus 3, B 3 4 and T that is minus 1 4 4 2. So first of all, simply to find midpoint of this transformed line, simply as we have A and B, simply find the midpoint of AB. M, that is midpoint of AB. Midpoint of AB is what? Minus 1 plus 3 by 2 and minus 3 plus 4 by 2. This one. What it is? This is 1 and 1 by 2. This is simply a midpoint here. Now transformed midpoint is simply obtaining by applying this T on M. Now transformed midpoint, or it is same as midpoint of A dash B dash, right? That is what? M into what? T. This is M star. So M is 1 1 by 2 and T is what? -1 4 4 2. And this product gives the answer 1.5. So here m star is what? 1 and 5. This is our final answer. From previous example, we got that if points A and B with us, simply we have to determine the midpoint of AB and then apply T on that midpoint. We'll get a transformed midpoint of a new line. Fine. Now, before going towards the next part, let me write one note. Under any 2x2 transformation, matrix, under any 2x2 transformation matrix, line AB is transformed to line A star B star. Similarly, if point P divides AB internally in the ratio m as to n, then transformed point P star divides transformed line A star B star in the same ratio m as to n. Second note, point on line A star B star have 1-to-1 correspondence with point on line AB. Have 1-to-1 correspondence with point on line AB. Example, show that under transformed T -1052 point P which divides AB in the ratio 2:3. Point P which divides AB in the ratio 2:3 is transformed to point P star which divides A star B star in the ratio A star B star in the ratio 2:3. Use A -1 2 and B 3 1. Solution. Consider T is given to us actually, but it is -1 0 5 2. We have to show if P is a point which divides AB in the ratio 2:3, then transform point P star must divides A star B star in a same ratio 2:3. So it is just like to show midpoint transform to midpoint. Similarly, P transform to P star. That is same as to prove this second note, that point on line A star B star have 1:1 correspondence with line AB. Means every point will transform to another point but in a same ratio. Okay. Now using section formula, let me find a point P first which divides AB in the ratio 2:3. So it is internal division. So our section formula will give us 2 into 3 plus 3 into -1 upon 2 plus 3 and 2 into 1 plus 3 into 2 upon 2 plus 3. How does it? If you have a doubt, let me tell. A x1 y1 and B x2 y2. And if a point P divides AB internally in the ratio m/n, suppose the ratio is m/n, then coordinates of a point P are, what are they? It is mx1 plus nx2 upon mx2 plus nx1 upon m plus n and my2 plus ny1 upon m plus n. This is a section formula. So from that we get this point P. Simplification of this is what? 3/5 and this is 8/5. So this P we are getting. Now what is transformed point P? So transformation of P is what? P into T. So it will be 3/5 8/5 into T -1 0 5 2, and that is 37/5 and 16/5. Call it as equation number 1. Now let's obtain a line A star B star. Transformed line A star B star is what? Applying T on a previous line AB. So we get A star B star is a product of line AB with T. AB is what? -1, 2, 3, 1 into T. -1, 0, 5, 2. This is 11, 4, 2, 2. You can check on your own. Therefore, again let's use section formula for P star. Using section formula. What we get? P star will be a transformed point, or it is nothing but a point obtained by, or point on line segment A star B star, which divides the line segment A star B star in the ratio 2:3. That one we have to obtain in that way. Okay. So 2 into what? 2 plus 3 into 11. This is x2 x1 upon 2 plus 3. Again 2 into 2 plus 3 into what? 4 upon 2 plus 3. So this is again how much? This is 37/5 and 16/5. Call it as equation number 2. So from 1 and 2, if we get that this P star is same as P into T. Therefore, P star equal to P into T. From 1 and 2. Okay, thank you. Next video we will see a slope of transformed line.